Alright, hey y'all, it's Miss Summers with your notes today on igneous and metamorphic rocks. So yesterday you should have taken some notes on the rock cycle. And over the next couple of days we're going to look specifically at the different types of rocks a little more in detail, specifically looking at how we can look at their characteristics and gain some understanding about where they were formed. So the first rock we're going to look at is igneous. You remember that IGN, that igna, means fire, and that helps you remember that igneous rocks are formed from magma or lava when it cools and hardens. So from volcanoes, essentially. Remember, the only difference between magma and lava is where it is. Magma is inside the earth. Lava is outside the earth. So different igneous rocks have different textures. When we talk about the texture of a rock, we're looking more so how it looks, its visual cues, things that we can observe. And that's based upon its crystal grain size. So some rocks like granite have very large crystals, like you can see those individual specks, while other rocks like basalt or obsidian have very small crystals or no crystals. Now, crystal size, what changes that from rock to rock, is determined by cooling time. How long it takes for the rock to go from a liquid state, when it's lava or magma, to a solid state, when it's a rock. So it is a direct relationship. The higher the cooling time, remember that's my independent variable on the x-axis, the longer the cooling time, the larger the crystal sizes are going to be. And the cooling time, we can tell what the cooling time is based on where the rock is formed. Rocks that form on the outside of Earth, because they're outside, they cool down relatively fast. So they're going to have smaller crystals. Whereas rocks that stay inside the Earth, they're insulated. They take a longer time to cool down. They're going to have relatively large crystals. So let's look at, that's literally what I just said. Write that down and put a big star next to it, because that's kind of the main idea behind igneous rocks. That's how this is what we can tell from them. If we can look at the crystal, we can see how long it takes to cool down. If we know how long it takes to cool down, we can determine if it's inside the Earth or outside the Earth. So igneous rocks can be divided into two categories, extrusive or intrusive. So extrusive, X-E-X, means out or outside. These form on the Earth's surface from lava. So this is like a picture of Iceland or Hawaii or somewhere like that. And you can see this lava, you can see it starting to darken. That's its hardening as soon as it reaches the Earth's surface. Obsidian is a good example of this. Alright, if you look at it, you don't see any specks, which means there are literally no crystals here. There was not time for crystals to form when this rock was made. So extrusive rocks are going to have glassy or fine textures. So glassy, like obsidian. BT dubs, obsidian is my favorite. You should know that. This is glassy. It's shiny. It doesn't have any speckles inside of it. That is no crystals. Fine is like basalt here. This is what happens at mid-ocean ridges at those divergent boundaries. The crystals are very, very tiny. There are little specks here, but you would need like a itty-bitty magnifying glass to see them. So, because there's no crystals or very tiny crystals, we know it cooled very quickly on the Earth's surface, and therefore it's igneous, or extrusive. Wow, cool. Yay. Our next type of igneous rock is intrusive. So I-N, it forms inside the Earth, like we have here underneath the Earth's surface. Granite is probably the most common of these examples. You probably have some laying around the house or your friend's house or at the Home Depot or whatever. Alright, you'll note one of the characteristics of granite, it has these specks in it. These really big specky specks. Those are very large crystals. So we call this texture coarse or very coarse. It's just the size of the crystals. I don't need you to know the difference. That just means they're really big. Again, remember, very large crystals indicate that it took a long time for this rock to cool down. The crystals had a chance to form. And if it takes a long time to cool down, that means it cooled down inside the earth. It's intrusive. So connect the dots from the crystal size to the cooling time to where it formed. All right. Our last type of igneous rock is kind of weird. It's kind of like a combination of both extrusive and intrusive, where some igneous rocks have large and small crystals. They'll have these really big crystals embedded in the smaller grain crystal mass. These are porphyritic. This is a sample of andesite, which is commonly porphyritic. It just means that there's two separate cooling events. So imagine this used to be magma. Little parts of it started to cool down, and that's where these large crystals came from, and then it cooled very rapidly afterwards, and that's where this small crystal mass came from. Just know that they have both. Alright, take a minute, pause the video, answer these 3 questions. Alright, and we should be back. You should have answered them. Hopefully you paused the video. If not, that was really weird. Number 1, lava flows. Where does it flow? It flows on the Earth's surface. A. Cooling rate affects the size of the grains of the igneous rock. So you could have put a lot of different things for this. You could have put direct relationship. As one goes up, so does the other. Longer cooling time equals bigger crystals. All that's cool. And lastly, crystals form in molten rock as it cools down. So A, your own words, A. Cool beans. Our next type of rock is metamorphic. Alright, metamorphic, to morph means to change. So like, with like bugs, like they undergo a metamorphosis. That just means they change from like babies to adults. With metamorphic rocks, they go from one type of rock to another type. And what happens, how they change, is under intense heat and pressure. Heat will come from the magma, and pressure comes from plate tectonics. So generally, these are going to be kind of near plate boundaries, where you have plates that are pushing up against one another. And because they require so much pressure, a lot of metamorphic rocks will form below the surface of the earth. And you can kind of tell, like, the relative depth based upon what the rock looks like. So, there are 2 types of structures. Oh my gosh, my dog is eating cereal off the counter. Simba, get down. Okay. So metamorphic rocks are classified according to their structure. If you look at these 4 pictures, you notice that some of them are different. These 2 kind of have stripes, whereas these kind of don't. Those classify what the rock is. So our first type is foliated. Foliation, things that are foliated just have stripes. So I think like a zebra is kind of foliated. Your skin is foliated because it's in layers. Those type of thingies. So pressure is what causes foliation to occur. It flattens mineral crystals and pushes them into bands based upon their density. So in order for there to be foliation, you have to have super high pressure, and it has to be directed from one direction. So imagine you have a cube and you're just squeezing it from the top only. You're not squeezing it from the sides or the bottom, just the top. That's a directed pressure. So slate is an example. Schist. This is schist, everybody. That's a funny word. And this is a real pretty foliated metamorphic rock. My dog's barking now. This is a pretty foliated metamorphic rock called gneiss. This is gneiss. This is a nice rock, everybody. You can see these parallel stripes. Alright? Our next kind is non-foliated, and it just means not striped. There are no visible parallel bands or stripes. So quartzite, marble's a very pretty non-foliated metamorphic rock. it's going to form under relatively low pressure or uniform pressure. So again, imagine you have a cube and you're pressing on it from the top, but you're also pressing on it from the sides. You're not going to get those bands to squeeze out. You can also have metamorphic rock form from high heat and low pressure. This is when rocks come into contact with magma, but they don't melt. That's called contact metamorphism. Okay, that's the main difference between igneous, y'all, and metamorphic. Igneous has to have melting and then cooling involved. With metamorphic, there's no melting. It's always a rock. It's just changing chemically. So let's talk a little bit more about the marbly marble. So I just said marble is a non-foliated metamorphic rock, and you might be thinking to yourself, well, Miss Summers, I have seen some pretty marble that has pretty stripes in it. Why is that not non-foliated? It's because the banding is not parallel. If you took these stripy stripes and continued them in straight lines, they would cross one another. If this were foliated, these stripes would be in a pattern, they would be in order, and they would be parallel. Okay, so even though there are stripy stripes, okay, you are correct, they're not parallel. Therefore, it is non-foliated. So, when we talk about metamorphic rocks, we will often talk about the parent rock. The parent rock is whatever that metamorphic rock was before it became that metamorphic rock. So, can any rock type become metamorphic? Well, if we look at this list, limestone, that's a sedimentary rock. Limestone will yield marble. The U stands for unfoliated, non-foliated. Shale is also sedimentary. Granite is igneous. Granite, remember, is that intrusive igneous with those great big crystals. It forms that nice rock. Oh, that's nice. But these next ones, this is interesting here. Slate, which is a type of metamorphic rock. Slate comes from shale. Slate is metamorphic. It can be further metamorphosized. So any type of rock can become metamorphic if it's exposed to heat and pressure. If it's exposed to heat and pressure. It does not matter what it started off. It can become metamorphic. Okay? So, what you're going to do with this information, you is going to go to Canvas. Alright, read over this information again. Kind of let it marinate on your brain. Your assignment is this. It's going to be in the Canvas. You're going to copy and paste these charts into a text box. Basically, what you're doing is I'm having you look at, I'm having you look at pictures of the rocks and then using that to complete the other columns. So I've done an example here for igneous. This is granite. I found a pretty picture of granite. I don't care which one you pick. And from this picture, I can see the really big crystals. So I know it's intrusive. I know it's intrusive because the big crystals mean it had a long cooling time. And big crystals is a coarse texture. Again, it doesn't really matter to me if you know the difference between coarse and very coarse. It's really irrelevant. I'm looking for the difference between like fine and coarse. Fine is small. All right, and I've also given you a freebie on this one. Pumice. Pumice has a weird texture, so I just gave that one to you. Metamorphic, you're going to do the same thing. And again, I've done this example. Nice is foliated because I can see it has these parallel stripes. They're in order. And I know that foliated rocks form under relatively high pressure. Alright, so I want to see if you can determine from the picture these other characteristics. Alright, so this is going to be due tomorrow at 2, I believe, is when I put the deadline for it. So please make sure. I'm not going to be there to remind you. But make sure you have that done so I can keep up with everything while I'm out. My hope is that I'll be back by next week. I know it's a really long time for me to be away, but that's just how cold and flu season goes. So everybody stay healthy. If you have any questions, you just shoot me an email. Okay, thanks.